Hello everyone. In the previous chapters, we learned about the impact of the operation of asynchronous paralleling on generators and systems. I believe everyone has a further understanding of the operation of power grid dispatching. This chapter focuses on learning the paralleling and decoupling operations between the generator and the power grid. The specific details are as follows. 1. Parallel operation between the generator and the power grid. 2. Parallel operation between the power grid and each other. 3. Decoupling operation of the unloaded tie line. 4. Decoupling operation of the load tie line. Now let's start this class. Firstly, let's review the conditions of synchronous paralleling of the power system. 1. Consistent phase sequence, and same phase. 2. Equal frequency. 3. Equal voltage. When it is difficult to adjust the frequency and voltage of two systems expected to be paralleled, the allowable frequency difference is not more than 0.5 Hz, the voltage difference of 220 kV and below is not more than 20% of the rated voltage, and the voltage level of 500 kV is not more than 10% of the rated voltage. When the dispatching meet the parallel conditions, through comprehensive regulation, the two power systems can operate in parallel. The generator and the grid can transmit power to the grid in parallel. How to achieve the parallel operation of the generator and the grid? As shown in the figure, the generator is connected to the large system through the OV line, with switches O1 and O2 on both sides. Green represents the switch in the open position, and red represents the switch in the closed position. The dispatching first adjusts the voltage and frequency to ensure that the generator and the large system meet the synchronous conditions. Next, the first step is to close the O2 switch on the large system side of the OV line, and the second step is to close the O1 switch on the generator side of the OV line so that the generator and the grid are paralleled to operate. Please note that the parallel order cannot be reversed. Similarly, let's learn the parallel operation between the grid and the large system. As shown in the figure, the small system and the large system are connected through the OV tie line, and when the small system and the large system reach the synchronous conditions, parallel operation is carried out. The first step is to close the O2 switch on the OV line's large system side. The second step is to close the O1 switch on the small system side of the OV line, which is the paralleling operation between the power grid and the power grid, according to the needs of the power grid operation. The systems need to be decoupled from each other. To ensure the safety of the power grid, attention should be paid when decoupling the system. Before decoupling the system, the active power at the decoupling point should be adjusted to 0, and the reactive power should be adjusted to the minimum. When it is difficult to adjust, it is generally advisable to choose the small system. When a small amount of active power is transmitted to the large system, disconnect the decoupling switch so that the frequency and voltage of the two decoupled systems are within the allowable range. There are two types of decoupling of the system: the decoupling of the no-load tie line and the decoupling of the loaded tie line. The decoupling of the no-load tie line is shown in the figure. The small system and the large system operate in parallel through the OV tie line, and there is no load transfer between the large and small systems. The decoupling of the system is relatively simple. The first step is to open the O1 switch on the small system side of the OV line, and the second step is to open the O2 switch on the large system side of the OV line, thus achieving the decoupling between the power grids. The decoupling of the loaded tie line is more complex. When running in parallel, the small system transfers 5 megawatts load to the large system through the OV tie line. Therefore, when decoupling, adjust the power of the tie line first to achieve no load transfer between the large and small systems. Then perform the following operations. First, open the O1 switch on the small system side of the OV line, and second, open the O2 switch on the large system side of the OV line, thus achieving the decoupling of the load tie line. Boys and girls, this class discusses the comprehensive regulation and control of the power grid, as well as the paralleling and decoupling operation of the power system. Paralleling and decoupling operation is a complex switching operation in the power grid, which involves many considerations and has a significant impact on the power grid. Sometimes, detailed calculation and confirmation are required. Before operation can be carried out, everyone must carefully understand and master it. In order to flexibly apply it in your work, please think about the paralleling operation of the loaded tie line. That's all for this lesson. Thank you.